find the domain of a rational function, what we're going to do is look to see where the denominator would be 0 and avoid that number. So for our first step, we take a look at the denominator, 2x minus 5, set it not equal to 0, because you don't want to divide by 0. That's why you want to avoid a 0 down there. Solve for x, and then divide by 2 here. And you've come up with the single number that x can't be. In other words, if you were going to make a t-chart, for example, and plug in numbers to graph that, this would be the one number that you can't use. So our domain, or the x values that we can use, have to avoid this number. If you think about it on a number line, here's 5/2. You can't use that number, but you can use all the numbers to the left and to the right of it, or from out here to negative infinity to positive infinity, just not that number. So when we write this in interval notation, starting from left to right, out here to negative infinity, all the way over to 5/2, because that's an open dot, we have a parenthesis on it. Means we can't use the number 5/2. That's why we have the not equal symbol here. Or starting it back up on the other side of 5/2, it can get close to it, just not be 5/2. We go 5/2 out to infinity. And that's the domain for the first problem. The second one, much the same. Set the denominator not equal to 0. This is a quadratic equation, so one way to solve this would be to factor it. And if you're not good with factoring, you can always use the quadratic formula if you remember that. This should factor though. Write down your 2 sets of parentheses, can't be 0, and then do backwards FOIL on it. So x times x is x squared. You look at the last number, positive 20, what multiplies to it, but then adds to positive 9. That would be a plus 5 and a plus 4. Set each factor not equal to 0. And then solve for x. So x can't be negative 5. Subtract 4 from both sides. X can't be negative 4. So if I, again, take a look at it on a number line, negative 5 and negative 4, these are the two numbers that I have to avoid. But all the other numbers on the number line are fair game. So again, starting from left to right, our domain is going to be starting towards negative infinity, all the way to negative 5. Then you're going to catch this piece in between, negative 5 to negative 4. Then you're going to catch this piece from negative 4 out to infinity. And again, parentheses on everybody, because you're not allowed to use the number negative 5 or negative 4, so no brackets. Let's scroll down a little further here. Okay. This one's, again, set the denominator not equal to 0, because you can't divide by 0. We're talking about putting values in for x. So we're just trying to figure out what those values are. So again, factor. This one's going to be a little bit more of a challenge to factor. But the idea is the same. 2x times x gives me 2x squared. Then I might need to multiply to get negative 3. So I only have a few choices, 1 times 3 or 3 times 1, and then the signs have to be opposites. You're going to need to plug in and then double check to make sure that the middle number works out. So if I plug in a 1 here and a 3 here, I'm going to put the numbers positive 1, negative 3. I need to check to make sure that my middle term is going to add up to negative 5x. So I have a positive 1x and a negative 6x add up to the negative 5x that I need. If I'd have flipped those numbers around, it wouldn't have come up to that middle number. Once I'm sure about the multiplying it back out to get this, I then go ahead and set each factor equal to 0, or rather not equal to 0, and then solve for x. So add 3 here, x can't be 3, subtract 1, divide by 2, and we come up with x can't be -1/2. So again, I have 2 places on my number line that won't work. -1/2, +3. All right, so open dots on both of those and fill in everybody else. So starting with -infinity to -1/2, open dot means parenthesis. On the other side of -1/2 to 3, and then from 3 out to infinity. Okay, the last one we have on this page, same idea. Denominators can't be 0. Notice I'm not doing anything with the numerator. It's all about the denominator when we talk about domain. Factor it. So I've got 3x times x gives me 3x squared. I need to multiply to get -1. So 1 times 1 is 1, but then I have to put in opposite signs because I need -1. So 1's going to be positive, 1's going to be negative, but I need to double check. So I multiply +1 times x, -1 times 3, and then add those two up. And I do get the -2x that I needed in the middle. So once I have that, I go ahead and set each factor not equal to 0. Solve for x, so take away 1 from both sides, divide by 3. And the same thing here, x can't be +1. So again, taking a look at it on a number line, -1/3 is smaller than 1, so I'm going to put them in order like that. I have -infinity out here, +infinity out here. These are the two numbers that you can't use. Everybody else you can. So it's -infinity to -1/3, or pick it back up in the middle here, -1/3 to 1, or 1 out to infinity. And that would be the domain for that function.